So yesterday we did simplifying, adding, subtracting, multiplying radicals. Today we are going to talk about dividing radicals. Right. A couple of things you need to know. So we all know the fraction bar means division, right? Hey, your answer is never allowed to have a radical in the denominator. Right? That's illegal. You can never leave a radical in the denominator, and you're never allowed to leave a fraction. Like number 4, you're never allowed to leave a fraction in a radical. So you can't leave a fraction in a radical. You cannot leave a radical in the denominator. Good news is, though, if there's a radical in the numerator and there's a radical in the denominator, you can divide those two radicals. So, for example, the root of 45 divided by the root of 5 is the root of 45 divided by 5 is 9. And again, we're just simplifying, we're not solving. So what is the square root of 9? 3. All right, number 2. There's a radical in the numerator, radical in the denominator. It is illegal, cannot have it, to have a radical in the denominator. Can I say 100 goes into 49? Can I divide those? No, 100 does not go into 49 evenly. But can I simplify these radicals? Yeah, aren't they both perfect squares? So what's the square root of 49? 7. What's the square root of 100? 10. No more radicals, so therefore no more problems. Great. Root of 108 divided by the root of 3. Does 3 go into 108? Yeah, so I can actually divide these. So if you can't do it in your head, you just divide. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, bring down the 8. 3 goes into 18 6 times. So now if I have the square root of 108 divided by the square root of 3, we end up with the square root of 36. What is the root of 36? 6. All right, what's illegal about number 4? What is illegal about number 4? Milo? Good, there's a fraction inside the radical, but the good news is that 6 does go into 150, so we are going to divide. 6 goes into 15 twice. 2 times 6 is 12. Subtract, bring down the 0. 6 goes into 35 times. So we're left with the square root of 25, and once again, we have a perfect square. What is the square root of 25? 5. All right, you all do number 5, and then we'll do number 6 together because it's a little bit different. All right, what'd you all get as your answer? 2. Anybody want to see me do this? Okay, so number 6 is a little bit different. We're dealing with something that we're not allowed to deal with. We cannot deal with a fraction underneath the radical. The other problem is I cannot simplify 3 and 16. This can't be divided, it can't be simplified. So what you do is you end up going from one illegal thing to another illegal thing, but the second illegal thing could sort of help you out. So what you're doing is you're going to go and make it a radical in the numerator, the root of 3, over a radical in the denominator. So I went from the illegal fraction in the radical to a illegal a radical in the denominator, which is okay. You're allowed to interchange those. Okay, and this does help us because when I make it the denominator the square root of 16, what do we realize 16 is? Perfect square. So our denominator becomes whole number 4. And our numerator stays the square root of 3. Is it okay to have a radical in the numerator? Absolutely. You're just not allowed to have a radical in the denominator. All right, what are your thoughts on number 7? Where should we start here? What are your thoughts? Bridget? Good. Simplify the fraction. 24 divided by 2 is 12. So now we have the square root of 12. 12 is not a perfect square, but can we simplify the square root of 12? Absolutely. So we're going to get 4 and 3, and then 4 becomes 2 and 2. So what is our simplified radical? 2 root 3. I think we all agree 54 doesn't go into 24 and 24 doesn't go into 54. But since they're both radicals, you can sort of simplify them. So what number goes into 24 and 54? Anybody know? What number goes into 24 and 54? Not 8, 6. Good. So we can divide these each by 6, and then what you end up getting is the square root of 4 over the square root of 9. So we sort of just simplified the fraction. And then I created 2 perfect squares. Square root of 4 is 2, square root of 9 is 3. So we sort of just changed it into 24 over 54 like that. We changed it into one big fraction and then just simplified that fraction. And that's how we got 4 over 9 and then split it. If you wanted to know like the actual steps that happened. Can we do something similar with number 9? Yeah, absolutely. So this whole idea is that because they're both radicals, I can simplify it. So I can divide by 8, and I end up getting the root of 8 over the root of 9, which once again are both perfect squares. So we get 1/3. I want you all to do number 10. So did you all start by simplifying it? What did we divide by? 5. So then we'd have the square root of 9 over the square root of 4. Again, both perfect squares. So what do we end up with? 3 over 2. All right, it's been nice when it's been working out like this, but let's see what happens when they don't end up becoming perfect squares. Let's see what happens. All right, number 1. I have whole number 1 over the root of 5. Right, what is the major problem right here, right now, in this problem? What's wrong with it? Adam? There is a radical in the denominator. We cannot leave a radical in the denominator, and at the same time, I can't divide, right? I can't simplify this anymore. So we have to do something. It's called rationalizing the denominator. Rationalizing the denominator means making this radical not a radical. And we can create equivalent fractions through multiplication. For example, if I have 1 over 2 and I multiply numerator and denominator by 2, I end up with a new fraction. I end up with 2 over 4, but isn't it equivalent to 1 over 2? Okay, so that's what we're doing. We're creating an equivalent fraction to 1 over root 5 that's not illegal, that doesn't have that radical in the denominator. And we do that through multiplication. As long as you multiply the same thing on the bottom that you do on the top, you're creating equivalent fractions. So now I have to think back to yesterday's lesson. What do we multiply a radical by to get it not to be a radical anymore? Olivia? Itself. So right now, if I multiply root 5 top and bottom, remember I kept telling you don't disappoint me, don't disappoint me. What's root 5 times root 5? Whole number 5. Remember this from yesterday? When you multiply a radical times itself, it's just the radicand, no more radical. And then I have 1 times root 5 is just 1 root 5 or root 5. can I simplify these, root 5 and 5? No, why can't I just cancel them out? Because one is a radical and one is a whole number. They are not the same. All right, let's look at number 2. Can I say 15 divided by root 3 is root 5? Can I do that? Good. I see you all shaking your heads no. Tell me why I'm not allowed to just say 15 divided by root 3 is root 5. Not Olivia. She just answered me. Somebody else. Show me that you know. Why? No. Somebody new. Okay, Chase.
Because one's a radical and one's not.
Good. We can't divide them. 15 is a whole number. Root 3 is a radical. They're not the same. We can't divide them. So what am I going to have to do here? I have to rationalize. How do I rationalize this? How do I rationalize? How do I get the radical out of the denominator? Multiply top and bottom by root 3. So in the numerator, this is whole number 15 times root 3. That's not root 45. This is 15 root 3. And in our denominator, root 3 times root 3 is whole number 3. I'm not done. Why am I not done? Erin? Good. Don't we see whole number 15 and whole number 3? I can divide those because they're both whole numbers. There's no plus or minus sign. The minute you add a plus or minus sign, you can't then simplify. But there's no plus or minus sign. It's all multiplication. So I can absolutely divide them. 15 divided by 3 is 5. So we end up with 5 root 3 as our final simplified answer. All right, let's look at number 3. Do we see that these are both radicals? Right, is there a plus or minus sign? No plus or minus signs. I keep stressing this because the minute there's a plus or minus sign, it changes everything. So right now, since there's no plus or minus sign, I can actually divide these. If there were a plus or minus sign, what I mean is if I have 2 plus root 3 over root 6, I couldn't divide these. I couldn't divide them because of the plus sign. It links them as a family. So if it's not divisible by everything, you can't just divide part of it. But if there's no plus or minus sign, if it's all just multiplication through everything, you can divide. Does everybody see the difference? Okay, so I can absolutely divide. So then if I divide by 3, what did I get? 2 root 1 over root 2, right? I just divided by 3. But what's the square root of 1? 1. So my numerator is 2. What's my denominator? Root 2. Can I leave it like this? I have 2 over root 2. No. Logan, what should I do? Multiply by what? By 2? By root 2. You got it. We're going to multiply numerator and denominator by the square root of 2. So here we're going to have 2 times the square root of 2 is 2 root 2. What's root 2 times root 2? 2. Now can I cancel out those 2's? Absolutely. So now we just have the square root of 2. All right, number 4, we're going to go from one illegal thing, which is the fraction underneath the radical, to another illegal thing. I'm going to make this the square root of 2 over the square root of 5. Caleb, tell me, what should I do to fix the radical in the denominator? Multiply by root 5, top and bottom. And then in the numerator, when I have the square root of 2 times the square root of 5, we end up with the square root of 10. What's root 5 times root 5? Not 5, whole number 5. Can I simplify anything further? No. All right, Connor, let's go on to number 6. We're skipping number 5. Connor, let's go on to number 6. Tell me, where do you see we think we should start here? Sure, and then what are you going to get?
5 root 1 over 5.
Perfect. And what's the square root of 1? 1. So what's my numerator? Just 5. Square root of 1 is just 1, so our numerator is just 5. So now I have 5 over root 5. Connor, keep going. What should I do now?
Here multiply radical 5 by radical 5.
And what else?
Multiply top by radical 5.
Okay, and then what do we get?
Just write this down. Top is 5 root 5, and then the bottom is just 5.
Good. One last thing we can do. Simplify the what?
2 5.
Good. They cancel out. So we just end up with root 5. Are we all good with this? Yeah? Okay, great. Let's go on to equations now. Let's go on to equations. Hey, yes, Connor. Oh, sorry. Yeah, you were walking me through. You didn't get to write it down. Okay, so now remember what I said yesterday. When we're just simplifying, we only account for the positive value. But what happens the minute we need to solve for an equation or solve for a variable? What do we have to do now? Liv? Good. We need to account for positive and negative. So here we have x squared equals 121. When we're solving square root method, that's what this is called, solving square root method. What you want to do is you want to get whatever is squared all by itself. Sort of like when you solve an equation, you want to get the variable by itself. When you're solving for a variable square root method, you want to get whatever is squared all by itself. So here is the x all by itself. Yes. So we have x squared equals 121. So to undo a square, we will take the square root, and you end up with x is equal to, now anytime we take a square root when we're solving, immediately put plus or minus. And then you guys should know this. What's the square root of 121? 11. All right, number 2, same idea. I have x squared equals 72. When we want to solve square root method, whatever squared has to be all by itself on one side of the equal sign. In this scenario, we have this. So to undo a square, we take the square root. Now, unfortunately, 72 is not a perfect square. So guess what I'm going to tell you to do? Cliff? Simplify it. So I think the best option is 36 and 2. So I go 36 and 2, and then 36 is 6 and 6. So what do we end up getting? X is equal to, what do I need in the front? Plus or minus 6 root 2. All right, let's look at number 3. 3x squared equals 54. Before I take the square root of both sides, what do I have to make sure? Not Olivia, somebody else. What do I have to make sure? Who else? What do I have to make sure of? Plecos, what do I have to make sure of? Good. The x squared has to be by itself. So I need to get rid of the 3, so I'm going to divide by 3 on both sides. So then I end up with x squared equals, is it 18? Yes. Now can I solve? Absolutely. To undo a square, we must take the square root. 18 becomes 9 and 2. 9 becomes 3 and 3. So tell me, what is x equal? X is equal to James? Plus minus 3 root 2. All right, what's the problem with number 4? What do I have to do? Charlie? Add 4. So we're going to have y squared equals 28. To undo a square, we're now going to take the square root. Break down our 28. I guess 4 and 7 is our best option. 4 is 2 and 2. So now we get y is equal to plus or minus 2 root 7. All right, let's do number 5. So we have 3x squared plus 3 equals 51. Do you agree I have to get rid of both of these 3's before I could square root both sides? So I'm going to subtract 3, and I'm going to get 3x squared is equal to 48. Then I still need to divide by 3. X squared is equal to 16. Square root both sides. What do we get for x?
Plus minus 4.
Good, Chase. Plus minus 4. All right, you all do number 6 by yourselves, and then we'll go on to something a little more difficult. All right, who's going to tell me how they did this? Okay, Adam.
So first you minus 2, so it's going to be 6x squared equals 72, and then you divide 6 on both sides, and then that'd be x squared equals 12, and then it'd be x equals plus or minus 2 root 3.
Absolutely perfect. You got this. All right, so let's look at number 7. I think these are the last 2 problems today. So let's look at number 7. We have x squared plus the quantity of 3 root 2 squared equals 67. All right, we need to get the x squared by itself, but before you can get the x squared by itself, what we need to do is we need to simplify the 3 root 2 squared. So remember, 3 root 2 squared is 3 root 2 times 3 root 2 equals 67. So we're going to now multiply this. You multiply the coefficients. 3 times 3 is 9. And then, don't disappoint me, what is root 2 times root 2? Rich? 2 equals 67. So now you multiply these two. So now I have x squared plus 18 equals 67. And now we should know how to solve this, right? We're going to subtract 18 on both sides. So we're going to have x squared is equal to 49, thank you. Square root both sides. X will equal plus or minus 7. What do I have to do for number 8? What do I have to do for number 8? Any ideas? Adam?
You have to do it again.
You got to square 2 things, right? Not a big deal. We have x squared equals 3 root 2 times 3 root 2 plus 3 root 3 times 3 root 3. So we'll have x squared equals, again, multiply these coefficients. So we get 9 root 2 times root 2 is 2, plus, again, now we're going to multiply these coefficients. 3 times 3 is 9, and then the radicals, root 3 times root 3 is 3. So now we have x squared is equal to 18 plus 27. So x squared is equal to 45. Now can we square root both sides? Yes. So we get x is equal to plus or minus 3 root 5. I will tell you, for the purpose of geometry, you see all our little factor trees, breaking it down, crossing it out, circling it. For geometry, that's perfectly fine. I will tell you, next year in Algebra 2, they will want you to do it in your head. They want you to simplify a radical as quickly as possible, and as quickly as possible is in your head. Just to give you a warning for next year. But for this year, the factor trees work. You're fine. All right, so we are done.